Now we will see what is correlation. We already had covariance. Now again why we are going to correlation? In covariance depends on units, that is percentage squares, and it is hard to compare, and there is no fixed measurement scale. It can go to any number. How we will compare them? Hence we are going for correlation. Correlation measures the strength and direction of a linear relationship between two asset returns. It tells, do they move together, how strongly, on a standardized scale from -1 to +1. Hence here is the correlation formula. Correlation of return on asset I and return on asset J is equal to covariance of return on asset I and return on asset J divided by standard deviation of return on asset I into standard deviation of return on asset J. That is the formula that is written here. Rho Ri Rj equal to covariance of Ri Rj by standard deviation of Ri into standard deviation of Rj. That is what mentioned here. Why we divide it by standard deviation? It removes units and standardizes the measure and forces the bounds between -1 to +1. Not just like covariance where number may go to n, whatever may be the number will come. Then how we will compare? Now we will see how we will interpret. If number is +1, perfect positive linear relationship. If -1, perfect negative linear relationship. If 0, there is no linear relationship. Between 0 to 1, some partial positive relationship, and 0 to -1, partial negative relationship. Okay. From the same formula it is derived that covariance of Ri Rj is correlation of Ri Rj into standard deviation of Ri into standard deviation of Rj. Here is an example. You see, there are 3 asset classes. In diagonal it is 1, that is correlation between the same asset class is always 1. Hence, now we will see some numerical example. We will go to exhibit 3. What exhibit 3 is saying? This is the exhibit 3. There are 3 asset classes. Okay. Now, covariance, variance, everything it is mentioned there itself. Covariance between bonds and MSCI is 38. Okay. Similarly, you can see variance of bonds and variance of MSCI. Now we are comparing between MSCI and bonds. So we are taking covariance of MSCI and bonds and variance of MSCI and bonds. Now convert the variance into standard deviation. So under root of variance itself is standard deviation. So we are getting 2 standard deviations. Standard deviation of bonds and standard deviations of MSCI. Now apply correlation formula. That is covariance divided by standard deviation. What is covariance between bonds and MSCI? Here you can see between bonds and MSCI it is 38. So 38 divided by standard deviation of bond into standard deviation of MSCI. Hence that is the correlation value, that is 0.2, that is above 0. So there is a slight relationship, slight small positive relationship between bonds and MSCI. Now we will see why correlation is better than covariance. Covariance unit dependent, correlation unit free. Covariance hard to interpret, correlation easy. and there is no bounds in covariance. In correlation there is a fixed bound -1 to +1, hence it is comparable. So correlation is not equal to causation. Zero correlation is not equal to independence. There may be some non-linear cases also. If there is a zero correlation, we have already told there is no relationship, but in some cases there might be a relationship, like U shape or inverted U shapes. There you won't find any linear relationship, but still there is a relationship. Okay, diversification improves as correlation decreases, but you have to remember that diversification works because correlations are less than +1, not because variances are low.